Welcome to today's deep dive, where we're cracking open some notes from a new school year. You are joining us as we decode a pretty surprising meteorological mystery from an advanced nature and innovation class.
Right, the class with Kesser and Steen. Yeah.
Exactly, yeah, Kesser and Steen. Our mission today is to figure out how a simple temperature drop sparks this invisible biological war in greenhouses and especially in vineyards. Imagine you are on an early morning bike ride and you see this soaking wet school bus, like just heavy water droplets everywhere.
Yeah, and you'd swear it poured all night.
Right. But the forecast showed a 0% chance of rain. Even the local fishermen predicted absolutely nothing. And there's this one quirky clue. The evening before, city tourists were wearing heavy winter coats to watch a solar eclipse at sunset. So, okay, let's unpack this, because what is actually happening to the environment here?
Well, to solve the wet bus mystery, we have to look at the weather data their teacher, Professor Hendricks, gave them. It really comes down to thermodynamics and water vapor because the air always holds invisible moisture.
Okay, so the air is just carrying this water around all the time.
Exactly, yeah. And the data showed these massive temperature swings. So like hitting near 30 degrees Celsius during the day and then plummeting all the way down to 12 degrees at night.
Oh, wow. Okay, so that rapid drop is why those tourists were suddenly freezing at sunset. You know, going from a hot summer afternoon to a chilly autumn night in just a few hours. I sort of picture the water molecules like energetic kids running around at recess.
That is a really great analogy, actually.
Yeah, and as the temperature drops, they lose that kinetic energy, slow down, and just huddle together into visible liquid. So cooling down literally forces the gas to turn into liquid because it just can't hold the energy anymore.
That is spot on. And that specific eviction point, that is defined as the dew point. It is the exact temperature where the air becomes fully saturated and condenses. But Steen had this really clever realization about the data, too.
Oh, right, about the humidity levels.
Yeah. You don't always need 100% relative humidity for this condensation to happen. Airborne particles, like dust or sea salts, they act as triggers even when the humidity is much lower.
That makes a lot of sense. But this whole daily energy shift, it isn't just some neat physics trick. Like Kesser realized in the notes, these dropping temperatures and rising humidity levels are a massive threat to plants, right? Especially in enclosed greenhouses, kitchen gardens, and, well, vineyards.
Oh, absolutely. It creates the ultimate breeding ground for powdery mildew, or Meldug, as the sources call it.
Meldug.
Yeah, it is a parasitic fungus that forms this gross white-gray coating on the leaves.
Wait, hold on. Doesn't fungus usually need a soaking, wet, damp environment to grow? Why is this suddenly a threat after hot, dry days?
I know, it sounds totally backward, right? But it is a fascinating biological paradox. Powdery mildew actually needs dry, windy weather during the day just to spread its spores around.
Oh, so the wind is doing the heavy lifting for the spores.
Yep. But then, to actually germinate, those spores require a really high relative humidity, like 90 to 95%. And they hate direct sunlight. Plus, they don't even need actual liquid water droplets to thrive.
Wow, so enclosed, humid greenhouses and densely packed vineyards at night are literally the perfect breeding ground.
Exactly.
So we've basically gone from noticing a wet school bus on a chilly morning commute to thermodynamics,
Yeah.
all the way to a full-blown plant pathology crisis.
Yeah, and if we connect this to the bigger picture, it explains why this is such a nightmare for farmers. Because powdery mildew basically cannot be cured once it takes hold. They have to rely entirely on strict prevention, bioorganics, and genetic resistance.
That is wild. Next time you step outside and see dew sparkling on your lawn, you really have to think about this invisible biological warfare happening at a microscopic level right under your feet. It makes you wonder, how might future crops be genetically engineered to completely outsmart this natural thermodynamic cycle? Definitely something to think about next time you check the forecast.